Hello everyone, in this lecture we are going to see about the dynamic routing protocol open charters part first. Now let's begin. The routing protocol specifies how routers communicate with each other. Routing algorithms determine the specific choice of route. The popular routing protocols are of two classifications, interior and exterior. Interior include RIP and OSPF and exterior include BGP. The main problems of this model protocol include the count infinity problem, the slow convergence problem, the large update packets, slow response to topological changes, as RIP updates only after every 30 seconds. This urges to the need for a linked protocol, that is OSPF. Stands for Open Shortest Path First. It is a standard protocol. It's an intra-domain routing protocol that is based on linked state routing protocol. It uses SPF or digital algorithm to find the shortest path. It has no restrictions on the hop count. It is a classless routing protocol. It only supports equal cost load balancing, and it provides authentication and authorization for routing messages efficiently. Areas. What is an area in OSPF? An OSPF network can be divided into subdomains called areas. An area is a logical collection of OSPF networks, routers, and links that have the same area identification. Areas limit the scope of route information distribution. The benefits of creating areas is to reduce the number of routes to propagate by the filtering mechanism and summarization of routes. Areas are identified by an unique area ID. All networks inside an area must be connected. At the border of an area, a special router called area border routers are used to connect two different areas inside a network. It summarizes the information and sends it to other areas for implementation. A backbone area is the core area which combines a set of independent areas into a single domain. The backbone area has a reserved area ID of 0.0.0.0. The OSPF backbone area is also known as Area 0. The backbone acts as a hub for inter-area network transmission traffic and the distribution of routing information between areas. Each non-backbone area must be directly connected to the backbone area. The backbone area must not be partitions, that is divided into smaller pieces under any failure conditions. The backbone area serves as the primary area and the other areas as secondary areas. The router inside backbone area is also known as backbone router. This is the diagrammatical representation of how many areas are connected within a single autonomous system in an OSPF routing algorithm. OSPF types of links. In OSPF, connection is called a link. Four types of links have been defined. They are point-to-point link, transient link, stub link, and variant link. Point-to-point link. A point-to-point link is a dedicated link that connects exactly two different communication facilities. It connects two routers without any other host or router in between. There is no need to assign network address to this type of link. Example of this type of link includes telephone line. Transient link. In transient link, several routers are attached to it. The data can enter or retrieve through any routers in the link. Each routers have many number of neighbors attached to it. Stub link. A stub link is connected to only one router. The data can enter and leave only through the single router, and only one directional message transfer is possible in stub link. Virtual link. When a link between two routers are broken or become failure, the administrator creates a virtual link between them using a longer path which passes to several routers, and this forms the virtual. The major fields of an OSPF packet header include version, type, packet length, router ID, area ID, checksum, authentication type, and authentication data. Version is a 8-bit field that defines the current version of the OSPF protocol. Type is also an 8-bit field that defines the type of packet being used. Message length is a 16-bit field that defines the length of total length including the header. Source router IP address is a 32-bit field that defines the IP address of the router that sends packets through all networks. Area identification ID is a 32-bit field that uniquely identifies each area. Checksum field used for error reduction on entire packet, excluding authentication type and authentication data field. The authentication type is a 16-bit field that defines the authentication protocol used in two areas of two types. 0 denotes none and 1 denotes the password. The authentication data is 64-bit data that is used to give the information about the authentication used in the OSPF. OSPF packet types. OSPF uses 5 types of routing protocol packets, which include hello packets, database description packet, link state request packet, link state update packet, and at last, link state acknowledgement packet. Hello package establishes and maintains adjacency information with neighbors. The database description packet describes the content of the link state database on an OSPF router. The link state request packet requests specific pieces of a link state database. A link state update packet transports link state advertisements to neighboring routers. And the link state acknowledgement packet acknowledges the receipt of a neighbor's LSA. The link state update packet plays a crucial role in OSPF operation by carrying the link state advertisements to other routers within a same OSPF area. It also indicates the type of link the LSA describes. The LSU packet serves as a heart of the OSPF operation. It is used by a router to advertise the state of its links. Each update packet contains several different LSAs, all having the same general headers. The link state update packet contains several fields which include link state age, link state ID, link state type, advertisement router, link state sequence number, link state checksum, length, etc. The OSPF protocol include the OSPF hello protocol. The hello subprotocol is intended to perform the following tasks within OSPF: dynamic neighbor discovery, unreachable neighbor discoveration, and ensure two-way communications between neighbors, ensure correctness of basic interface parameters between neighbors, provide necessary information for the election of the designated and backup designated routers on a LAN segment. Database description message packet. It is used mostly during the database exchange process. The first DBD packet is used to elect the master and slave relationship and to set the initial sequence number entered by the master. The router with the highest router ID becomes the master and initiates the database synchronization. The master sets the sequence number and the slave acknowledges it for transmission process. After the master and the slave are elected, the database synchronization starts. In this process, the headers of all the LSAs are exchanged with the neighbors. The database descriptor packet format includes the 20-byte OSPF header, interface MTU, options, 1-bit, M-bit, MS bit, DBD sequence number, LSA header, etc. When 1 bit is set to 1, this means that this is the first packet in the database descriptor exchange process. When M bit is set to 1, this means that more packets will follow. When the MS bit is set to 1, this is used for master and slave. If it is set, it means that the router is a master in the database descriptor exchange process. If this bit is set to 0, it means that the router is a slave. The DBD sequence number field contains a unique value set by the master. The sequence number is used during the database exchange and only a master can increment the sequence number. The LSA header field consists of a list of the link state database headers. Link state request packets. A link state request packet is sent if part of the database is missing or out of date. The link state request packet is used to retrieve that precise piece of database information that is missing or lost. The link state packets are also used after the DBD exchange process is finished to request the LSAs that have been seen during the database exchange process. Even here illustrates a linked request packet format. It contains 25 OSPF header, LS type, linked ID, advertising router. LS type identifies what type of LSA is being requested. The linked ID represents the linked ID of the specific linked advertisement. Advertising router contains the router ID of the router originating this LSA. Link state acknowledgement packet. The link state acknowledgement packet is used to acknowledge each LSA. This packet is sent in response to the link state update packets. Multiple LSAs can be acknowledged in a single link state acknowledgement packet. This packet is responsible for the reliable delivery of the link state update packets. The below figure illustrates the link state acknowledgement packet format. The link state acknowledgement packet consists of only two fields, a 20-byte OSPF header and the link state advertisement header. Now, let's talk about some advantages and disadvantages of OSPF. Advantages of OSPF include unlimited hop count, open standard, loop-free, fast convergence. Some disadvantages of OSPF include complex design, supports only equal cost load balancing, and consumes a lot of CPU resources. In this PPT, we have learned all the main concepts of OSPF And with this, I come to my presentation. Thank you, everyone.